हेलो स्टूडेंट्स। तो आज हम यहाँ पर आए हुए हैं 9th क्लास के लिए फिजिक्स से एक चैप्टर लेकर के फोर्स एंड लॉज ऑफ मोशन। सो अ वेरी गुड मॉर्निंग टू ऑल ऑफ यू। ट्राई टू अंडरस्टैंड व्हाट इज दिस। एक्चुअली वी आर गोइंग टू टॉक अबाउट फोर्स एंड laws of motion. Very important topic it is. Push or pull is called force, we all know, and formula of force is equal to ma, mass into acceleration. Force is a vector quantity, acceleration is a vector quantity. Definition of acceleration is rate of change in velocity. Acceleration is also a vector quantity. Velocity is a vector quantity. This is initial velocity, it is also vector quantity. So let us see the SI unit of force. The mass of the SI unit of mass is kilogram and SI unit of acceleration is meter per second square. So commonly it is known as Newton. Means to say that Newton is equal to kilogram meter per second square. Clear? Now, what is the meaning of 1 Newton force? Write down 1 everywhere in this expression. It is 1 kilogram meter per second square. So, 1 Newton force is defined as in this way. If a force of if means to say that much force is called 1 Newton. If a force applied on a body whose mass is 1 kilogram accelerates it at a rate of 1 meter per second square, that much amount of force is called 1 Newton force. After knowing about it, we should discuss about the traditional method of finding out the formula of force. Since we all know that acceleration is, what will happen? Inversely proportional to m. Acceleration is inversely proportional to m, and acceleration is directly proportional to f. So combine combine these all statements. We have acceleration is directly proportional to f by m, and acceleration is equal to k f by m. Finally, you see in SI unit k is equal to 1 in SI unit. K is 1, so acceleration is equal to f by m. Therefore f is equal to what is ma. Therefore f is equal to ma. F is equal to m a, mass into acceleration. This is an experimental explanation, but in modern era we discuss about on the basis of rate of change in momentum. See, rate of change in momentum rate of change in momentum is to be directly proportional to force. So F is equal to kmv minus u by d. In SI unit, k is equal to 1, F is equal to m v minus u by t is equal to m, and see this expression. What is this? This is acceleration. Therefore, F is equal to, what is m a? F is equal to ma. Very simple logic it is. You have to use this statement, rate of change in momentum. This is the rate of change in momentum. All of you can see here. After knowing about it, we should know Newton's laws of motion. Newton's laws of motion. There are 3 laws given by Newton, Sir Isaac Newton. And what is this? These all laws? What's these all laws are? A body will remain at rest. A body will remain at rest or in uniform motion until and unless an external unbalanced force is applied on it. See all of you carefully. What is this? This law is called law of inertia. Law of inertia. Clear? Second law, rate of change in momentum. Second law, rate of change in momentum is to be directly proportional to the applied force. This law is called to find out the formula of force. To find formula of force. Formula of force. Third law, to every action there is an equal and opposite reaction. Remember, this law is called action and reaction law. Action and reaction law. So how can we understand about it? Moreover, this law is the real law of given by the Newton. Real law of motion. Clear? So now try to understand one more thing. To find the formula I have already deduced there. See, what is the formula? Formula is equal to F is equal to mv minus u by t. Clear? Suppose initially no force is acting on the body, then it will be 0 and it will be like this. And it will be like this. Remember, now we have the multiplication of two quantities, mass and the difference in velocities, final velocity, initial velocity. Mass will never be 0, so it is 0. Therefore, we can write v minus u is equal to 0. Therefore, v is equal to u. This is only possible if the body is at rest, or moving with uniform speed. So, from second law, we found first law. Clear? Now, third law we can also find out from that. We can also find out But if you are able to understand, then you can understand. If not, doesn't matter. Clear? Think about it. Suppose we have two bodies. Suppose we have two bodies. What are the bodies? Body 1 and body 2. Suppose there are two bodies. Body 1, body 2. Suppose this is body 1, this is body 2. Now these two bodies are coming here and colliding to each other. Clear? So force exerted by body 1 on body 2 will be F12. Clear? Moreover, now suppose we discuss about its momentum. In terms of momentum, now we should understand. Clear? Because we all know that rate of change in momentum remains always constant. Suppose the momentum exerted by body 1 on body 2 is P12. The momentum exerted by body 2 on body 1, this is the body 2 on body 1, is P21. It remains constant according to law of conservation of momentum. Differentiate both sides by time interval t. Differentiate both sides by time interval t. Both are equal. Clear? Both are equal. So P12 plus P21 बराबर K. तो आप इसको डिफरेंशिएट कर दो टाइम के टर्म में. डी बाई डी टी ऑफ P12 प्लस डी बाई डी टी, सी ऑल ऑफ यू, P21 21 actually is equal to d by dt of K. See, this is rate of change in momentum. Momentum divided by time. It will be F12 plus F21 and differentiation of constant term is 0. So what will happen? It will be F12 is equal to minus F21. Minus F21. Clear? Let us change the direction. So it is very important. Direction is very important in order to understand the vector quantities. So from second law we have reached here, that is equal to, see here, force, both forces are equal but opposite in sign. So there is an equal and opposite force. There is an equal and opposite force acts on the system. There are many numericals based on it, on the basis of law of conservation of momentum and even force, acceleration. Clear? Many applications are there. Law of conservation of momentum, it is also very important for all of us. See, what is law of conservation of momentum? Law of conservation of momentum states that during collision, the total momentum remains constant and conserved. Total momentum remains constant and conserved. Suppose we have two bodies and at a time interval of t, these two bodies are colliding. Mass is m1, mass is M2. M1, M2. U1, U1, V1, U2, V2. Clear? See all of you. So the time interval is T. The time interval is T. Both are equal. What is the change momentum here? Rate of change momentum here? V1 minus U1. Actually it should be M1 V1 minus M1 U1 divided by T. There M2 V2 minus M2 U2 divided by T. See, rate of change momentum means to say that it is force. Rate of change momentum is called force. Force exerted by body 1 on body 2, that is F12, and here it is actually what is F21. According to third law, these two forces should be equal and opposite. Means to say that F12 should be equal to minus F21. Now put these all the values. M1 V1 minus M1 U1 divided by T is equal to minus M2 V2 minus M2 U2 by T. This T and this T gets cancelled, and we have M1 V1 minus M1 U1 is equal to minus M2 V2 minus M2 U2. So now come here. If you are not getting, please tell me in the comments. I will improve. What will happen finally? M1 V1 minus M1 U1 बराबर minus M2 V2 प्लस M2 U2. सभी टर्म्स को आपको प्लस बनाना है. इसको आप इधर ले आइए और इसको इधर ले आइए. तो M1 V1 प्लस M2 V2 बराबर M2 U2 प्लस M1 U1. What is overall? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Total momentum before collision is equal to total momentum after collision. Clear? So, thank you all of you. Keep on watching my videos, providing continuously for your convenience. During this lockdown, enjoy my video or search in Google by saying that Physics Numericals by Birendra Prasad. Physics Numericals by Birendra Prasad. You search in Google also, so many videos are there related to maths and physics. For the time being, you solve all the numericals given in the NCERT based on these all. Thank you all of you.